A-level pure mathematics, looking at a typical exam style question involving coordinate geometry, okay, in roughly, 5 minutes. Okay, let's go. This is question number 1. It says the straight line, L1 passes through the points A320 and B130. The straight line L2 has gradient 1/3 and passes through the point 0,5. The point D is the intersection of L1 and L2. Show that the length of AD is in the form K root 5, where K is an integer. Well, first of all, L2 here is nice and easy to write here. So L2 is Y is equal to 1/3 X, or X over 3, plus 5. That's obviously quite nice and easy in the form y is equal to mx plus c, where m is your gradient and c is your y-intercept. Now for L1 here, obviously it's slightly more trickier. We're going to obviously work out the gradient first of all. The gradient of L1, is the change in y divided by the change in x. So it's a difference in the y coordinate. So it's y2 subtract y1. So second y coordinate subtract the first y coordinate, all divided by the second x coordinate subtract the first x coordinate. So I'm going to get negative 20 on the top divided by 10, so minus 20 tenths, which simplifies to negative 2, or minus 2. So the gradient of L1 is y is equal to negative 2, or minus 2. So as y is equal to minus 2x plus c. To work out the plus c, I can substitute in either the coordinates of A or the coordinates of B to work out what c is. I'm going to sub in B just to make it, for the sake of ease. So we have 0 is equal to minus 2 multiplied by 13 plus the c, Rearranging this here, so I'll do it down here actually. So rearranging this, I'm going to get 0 is equal to minus 26 plus c. Adding 26 to both sides to balance this respectively. 0 plus 26 here is equal to 26. So 26 is equal to c. So the equation of L1 is now y is equal to minus 2x plus 26. That first part is now done. Now, the second part says that they intersect, so the two lines intersect, at point D. So I've now got to equate both equations, and work out the coordinates of D, for that. So I'm going to have minus 2x, plus 26, is equal to 1/3 x plus 5. So yeah, we've got an equation here. I'm going to multiply everything through by the 3. So I'm going to get negative 6x. 26 times 3. Well, let's obviously work it out to the side. Of course, you can obviously reach for your calculator here, but I'll do obviously by hand, for the sake of ease. For the purpose of this video, 6 times 3 is going to be 18. So 8 carry the 1. 3 times 2 is 6. Plus 1 actually is going to be 7. So we've got 78. And then if I multiply 1/3 x by 3, it gives me just x, or 1x. And then 5 times 3 is going to be 15. I'm now going to subtract x on both. Oh no, sorry. I'm now going to add 6x to both sides to get all my x's on one side. So I have 78 is equal to 5x plus 15. Subtract 15 on both sides and then divide through by the 5. So we're going to have 78 minus 15 all over 5 will give me the value of x. So that should give me 63/5 for x. So it's a bit like a nasty number there, but I'll leave it as a type of fraction. I can now sub this into either equation to work out the coordinates or the point of y, or the value of y. Okay, so if I sub it in actually to this one, it's a bit more easier, or otherwise it doesn't actually mean differences here. So I'm going to have minus 2 lots of 63 fifths, and then plus the 5. So I'm going to have y is equal to minus 126 fifths plus 5. Okay, obviously 5 can be written as 25 fifths. So y would equal to minus 101 fifths, okay, when you work it out, okay? Because this would obviously go to 25 fifths, and then when I'm adding fractions, same denominator, I just add the numerators, minus 126 plus 25, so being very careful here, the number gets bigger. Okay, so it's minus 101, sorry, it should be 101 fifths, not 105 fifths, sorry. Okay, so that's the coordinates of D. So D has the coordinates of 63 fifths and minus 101 fifths. Okay, so I'm going to work out the length of AD. Okay, so I'm going to work out, like the actual length of AD. So if we just draw like a little picture of this here, just so we've got an idea of what we're actually looking at. Okay, we're looking at like the length here between that two coordinates. So that's going to involve using the Pythagoras theorem. Okay, so this one looks like this roughly. Okay, like that. Okay, this one is going to look like that, obviously much steeper. Okay, obviously it is meant to obviously intersect is somewhere obviously down here, but obviously obviously let's move this horizontal line up. Okay. Let's obviously fix this quickly. So this one here is going to look, okay, so yeah, it is meant to intersect, okay, yeah, rough. Obviously, I think my sketch obviously is a bit more trickier, but yeah, it is meant to intersect here, somewhere down here, basically. Okay, which I don't know how, because one of them has to go through, yeah, actual like positive part. Okay, but the idea here is that this is meant to cross here. Okay, or somewhere down here. Okay, so that's point D. Okay, so yeah, to work out the length of AD, okay, I'm going to work out the actual difference in the length here. So yeah, it's going to be the square root of the difference of them squared. So this subtract this, so 63 fifths. Okay, subtract 3, so I write it as 15 fifths. Okay, all squared. So that's that one, x minus x1 squared plus y minus y1 squared. Okay, square rooted. And then I'm going to have this subtract this. Okay, yeah, so it's distance. Okay, difference in distance. I think there was like a mistake you guys here, because there's no way, because I meant to get like an integer. Okay, the 5 here looks promising. Okay, so I can write that as 100 fifths. Okay. Fifths all squared. Okay, so working this out, what do we get? Well, here I'm going to get 53, so I'm going to actually get 48 fifths all squared. Okay, okay, plus, well, this will actually give me here minus 201 fifths, okay, all squared, okay. I think, guys, yeah, I think there is an issue here with the wording of this question, because if I just work out, let's just work out what 63 fifths is on my calculator just quickly. 12.6. So if I minus 3, I'm going to square that. Okay, 92.6. Okay, so doing this on my calculator, I end up getting like a weird decimal answer. Okay, so we want to work out, okay, the distance of AD. So the problem is, though, graphically, that's not actually correct, actually, because it's not obviously meant to cross there. And no matter how I actually draw the shape, okay, it always crosses at like a positive quadrant. For that, okay. But to work out the distance, you work out the difference in the x coordinates and then square it, and the difference in the y coordinates and then square it. Okay, but your answer is meant to obviously give you like a third. Okay, it's meant to obviously give you, like 2 root 5, or whatever it is, 2 root 5 actually, or 3 root 5. Okay, but if it, like working this out, on my calculator, I got like a weird decimal answer. So if I square 48, sorry guys for like going a bit over here. So if I square 48, what do I get? Well, I'm gonna get 2,304 all over 25, and then I'm gonna be adding this. Here I get like a massive number, so let's actually delete this bit, so I've got a bit more space. Okay, so if I square 201, 42,705 all over 25. Again, it's obviously going to be square rooted. Okay, I must be on like the right lines here, because obviously the 5, obviously the bottom edge here, but if I just add 2,304, okay, I get the square root of 45,009, which is not a square number as far as I'm aware, okay, over 25. So square root that, yeah, I get a decimal. So I get a decimal, okay, I get root 45,009, okay, all over 5. And I don't know, I don't know any like square numbers that go into it, because the square root of that is not a whole number. The square root of 45,009, okay, is 212.1532464988457 for that, okay. So that's as far as I can go with that, okay, for that, okay. Unless I'm not finding difference, unless I'm actually adding it instead. So let's obviously try actually adding actually to this, and then obviously square root. Let's just see what happens. So I'll leave that number there actually just for like a second there. So if I add the length here, yeah, and then square it here, so if I add it, so I'm going to have the square root of 63 fifths plus 3, okay, all squared, plus this minus this, add this, so minus 101 fifths, okay, I can just obviously write that, yeah, as 100 fifths, okay, all squared, which is square rooted. Sorry about having to mind it. Let's just delete all this just for a second, and we'll come back to that. Okay, so that is one possible answer that I got for that question. Okay, although yeah, k is not actually an integer in that case. So here I can write 3 as 15 fifths. Okay, now I'm going to obviously be adding it, so hopefully it's a bit more easier. So I'm now going to have 78 fifths. Okay, all squared, plus minus 1/5, all squared, square rooted. Okay, this is a pretty nasty, I think, 8-mark question. Obviously, yeah, you obviously can use a calculator here, so calculator, like, yeah, obviously would actually suffice for this question. So this part, I'm gonna get 1/25. Okay, let's obviously square. So I'm gonna get 25 on the bottom there. Squaring 78 squared is 6,084. Okay, so this is looking at a bit more promising now. Okay, square rooted. So plus 1, I'm going to get the square root of 6,085. So the square root of that over the square root of 25. Square root of 25 is, we should know that's equal to 5, because 5 5s are 25. Okay, the square root of this number. Okay, we actually get a decimal, but we get a nearly whole number. So yeah, it actually goes to 78. Okay, 0.006 here. So that's as close as we'll get actually here. So that will actually give us here 78 fifths. Okay, and the other one here was the square root here of 49,005. Over 5. Okay, so I'm going to go with here that k is equal to 78 because I can't find any other solution. Remember that to work out the length of a of 2 points, you're actually meant to work out the difference, but the difference didn't give me like the right answer unless you're obviously wrong. Okay, but yeah, that is the closest that I get you. That was actually the closest number. It's actually 78.006490999302557. Okay, but that is the closest that I could get. So sorry that I actually waffled on here, and sorry that I went over like the 5-mark minute. Hopefully you can forgive me here, but hopefully that makes sense. So to work out the length here of 2 points, yeah, you're meant to, or you're supposed to find the difference in the x coordinates, square it, the difference in the y coordinates, and then square it, and then obviously square root the whole thing using Pythagoras. Okay, because the formula I believe is a square root of x minus x what all squared plus y minus y1 all squared, obviously square rooted. Okay, so it is meant to look something like this. Okay, where obviously x and x1 are your coordinates, plus y minus y1 all squared, square rooted. Okay, when I did it that way, I got this answer. I got 49,005 square rooted all over 5. Okay, and that also gave me, like a decimal answer. I think it gave me 202, whatever it was, 212 point something, whatever it was. For that, okay, but hopefully that obviously makes sense, guys. Yeah, but again, if I've made a mistake here, I would still get method marks. Okay, I think if this last part here, is a bit more trickier, but I think up to this sentence here, I was happier with obviously the corners of D. Okay, happy with what L1 and L2 were. So I think personally, I would have got, I think, even 6 or even 7 marks here, because although I didn't, maybe the final answer might have actually been wrong here, or maybe it's not fully correct. I showed full workings, which obviously allows an examiner to see where it is. I actually went wrong here, but hopefully, sorry if I actually confused you here, but hopefully it actually makes sense. But obviously, let me know in the comment section here what you actually get for this answer. Yeah, because it's quite like a challenging quick question here. But I think this question here, I think there was actually mistakes here in like the way of this question. Yeah, because it's not actually been written properly. And when I tried to obviously sketch it like graphically, the coordinates kept crossing in like the positive quadrant for both X and Y, which obviously told me that my point D must obviously been wrong here. But obviously I double checked in the mark scheme. Not the mark scheme, sorry, yeah. I double checked, yeah, the substitution, yeah, sorry. Okay, but let me know, yeah, what the correct answer is. Let me know, yeah, if I got it obviously right. But yeah, sorry if actually, yeah, like, uninstalling actually a bit of obviously, yeah, complex there, but hopefully you can forgive me. Okay, any questions, any queries, put it in the comment section. Thank you so much for watching. Don't forget to like, don't forget to comment, don't forget to subscribe, and I'll see you all inside for the next future video in July. Okay, bye for now. Take care. Okay, good luck with your end of year 12 assessments or end of year like AS pure math assessments, and good luck with some holiday revision. Okay, and I'll see you soon. Okay, bye for now. Take care. All the best, guys.